Good morning. We're going to get ready for the math lesson, and we have finished Unit 1. We're moving into Unit 2, and as you can see by the screen that you're looking at here, we're going to be working with rational numbers, and we're going to be focusing on elevation and temperature. So to get you started with what you're going to be looking at and how you should be thinking about it, let's look at the title slide that I have here, and you can see there's mountains and a lake. You've got the sky in the background, and if you look at the left side, there is a vertical number line, and notice where the 0 is. It is indicating sea level. This is where the land meets the water, sea level. Anything above sea level is an increasing or a positive number. Anything below sea level is a decreasing or a negative number. So this kind of sets the mindset of what we're going to be looking at, and be thinking of times when either you've been hiking up a hill, or if you're at the beach, or if you're going down into maybe a cave or a ravine and it's below, you're having to climb down. So that'll kind of give you an idea of what we're looking at. But as we always do to get started, what are we learning? Well, today we are learning that positive and negative numbers are used together to describe quantities having opposite directions or values. Why am I learning this? Well, positive and negative numbers are used every day in many different ways. It is important to understand what these numbers mean. It is also an important concept in 7th grade math. So this is helping us to be successful in math next year. Your success criteria. You will be able to read the description, draw a vertical number line. Remember, vertical is top to bottom, not side to side. A vertical number line, and add interval ticks, those little marks that show you the interval amount that it's either increasing or decreasing by. And determine if the number is positive or negative based on the relationship to 0. So we have a couple of vocabulary words, and the first one is rational number. And a rational number is any positive or negative integer, decimal, or fraction, or any number that can be made by dividing one number by another. The term comes from the word ratio. And if you're looking at a fraction is a type of ratio. So a rational number is going to be something where you can divide one number into another, and that's going to be your rational number. Positive rational numbers, terms that will indicate a positive rational number above sea level or above 0. Negative rational numbers below sea level or below 0. So now, let's take a look at these examples that I have here. And here I have a mountain, and notice this dotted line, sea level. This is 0. And as you go up this mountain, you're increasing in elevation. And at the top of this mountain, you are 1,025 meters above sea level. That would be a positive number. Now let's come back to sea level. And as this dips down, look where the water level is. Where the water and land meet, that's your sea level. As it dips down, you have negative numbers. And at the base of this, I'm going to call this a lake. At the base of this lake, you're minus or negative 155 meters below sea level. So that's one example of what we're talking about. Let's take a look at the iceberg. Again, here is 0 right here. And the part of the iceberg above the water is above sea level. The part of the iceberg below water is below sea level. And looking at this example, we have a boat, and this boat is on top of the water, and it's where the water meets the land. So that boat is at sea level. We have a very lucky person here who's hang gliding from the back of this boat, and that person is above sea level. we have some fish going at different levels below, and those are all below sea level. And we have an old pirate ship that's way down here at the ocean floor, and that is very much below sea level. So we have sea level, above sea level, below sea level. And our last picture here shows the same thing. This guy in the boat is at sea level. Now look where this 2 is indicated. And that's because the man is not right in the water. He's in the boat. So he is 2 feet above sea level. Look at his fish hook. That hook comes down below the water level, and that is 6 feet below sea level. And there's the surface of the lake. And this is the same picture we saw, and the iceberg was the same thing that we just looked at. So now, problem of the day. These are 2 review questions. A case containing 12 cans of corn costs $9.64. How much does 1 can cost? Your second problem of the day. And we have someone buying 32 7/10 ounces of lentils. She split it into 3 equal portions. How much was in each portion? Well, the first thing you need to do is write this in working form. But in order to write it in working form, you must determine what operation you're going to use for that. If I know there's 12 cans of corn, and this is how much the 12 cost, how would I find out the cost of 1 can? I know there's 32 7/10 ounces of lentils, and it's being split into 3 equal portions. How much was in each portion? So use those hints to help you figure out what you need to do and to complete your problem of the day. I am going to give you 4 minutes. So Mrs. Nash is going to pause the video here. You're going to have 4 minutes to calculate this, and then you will be able to continue with the rest of the lesson. So pause here and check back in 4 minutes. Okay, so I have no doubt you decided that you would need to divide. So we're going to have 12 being divided into $9.64. When we're dividing a whole number in a fraction, or decimal, remember you put your decimal point in the question, and I'm going to look at 12 goes into 96, or 12 times what number is 96? And that would be 8. 8 times 2 is 16. 8 times 1 is 8. 1 more is 9. Subtract 0. Bring down the 4. And 12 will not go into 4. Remember, we're writing this as a decimal, so I'm going to put 0. Multiply back, 0, 4. I'm going to put some more zeros in my dividend. Bring 1 down. 12 goes into 40. Well, that's going to be 3 times. 3 times 12 is 36. And some of you are already noticing, or you've already noticed, at this point, you're going to have a repeating decimal. And remember, your directions when we've done this has said to take it out to 3 numbers after the decimal point. 1, 2, 3. So the cost of each can is going to be 80 cents. We're going to look at the 0 and the 3. This is not going to increase. So now we have 3 servings. that are going to go into 32, decimal point, 7 or 32, and 7/10. Okay? And when you're doing your division, okay, you subtracted, brought down, bring down your 7, and you have your answer. Okay? If you had any mistakes with that, make sure you fix it in your book. And now, let's go to teacher input. Remember, teacher input, pencils are down, looking up here at the screen. And I have an image of a mountain and water. And here I have a sailboat at sea level. Well, if this is at sea level, that's where my 0 is going to be. Going up the side of this mountain, there is a hiker. And this line is at plus 100 feet. Or another way to say that is the hiker is 100 feet above sea level. Here's sea level. This is increasing above sea level. Then we have a scuba diver. And I'm looking at the number line here. And I'm looking at where the scuba diver is. And when I come across to the amount, that's negative 50 feet. Or the scuba diver is 50 feet below sea level. Okay? So remember, when we're looking at the examples, talking about the examples, we're going to use at sea level, which is 0, above sea level, or below sea level. One more teacher input. This is a thermometer. Well, a thermometer is basically a vertical number line that you're going to use to check and see if the temperature has increased or decreased beyond a certain amount. So the temperature was 10 degrees below 0 in the morning. So I'm looking at this thermometer. This is the level it was in the morning. And at noon, the temperature was 20 degrees above 0. So here's 0, 20 degrees above 0. And at bedtime, the temperature has fallen to 0. Well, it was at 20 and it fell back down to 0. So let's take a look at these numbers again here. The temperature first thing in the morning was 10 degrees below 0. So from negative 10 to 0 is 10 marks. If this is a negative 10, the opposite of negative 10 is positive 10. And they're both 10 spaces from 0. Negative 10 is 10 spaces from 0. Positive 10 is 10 spaces from 0. If I look at the 20 degrees, when it increased at noon, it went 20 degrees above 0. Well, 20 degrees above 0 is a positive number. The opposite of 20 degrees above 0 is 20 degrees below 0. So if I want to find an opposite number, here's 20. I'm going to count down 20. That takes me to 0. If I count down another 20, it takes me to negative 20. So if I'm looking at a positive number, my opposite number, it's going to be the same number, but it's going to be that distance from 0. 20, the opposite, negative 20. Negative 10, the opposite, positive 10. Now, let's put this information to work. Structured guided practice. Your directions, read each description and write the rational number. Remember, when we're saying rational number, this is going to be a positive or a negative number. The camper height, 40 feet above sea level. One thing I'm going to have you do whenever you work these out, let me get an arrow here that's going to look a little better. I'm going to have you draw your number line. And that's going to help you visualize what we're talking about. So here is my number line. And if this is above sea level, remember sea level is at 0. So I'm going to put a 0 and sea level. And you're doing this in your book as well. Sea level, draw your vertical number line, label sea level, and the hiker or the camper height, 40 feet above sea level. So I'm going to graph that on the number line. Here's 40 above 0. A submarine sank 120 feet below sea level. Remember, when we're talking below sea level, I'm going to look at 0, and I'm going to go down to 120 feet below sea level. Now, the third question. What is the opposite elevation of the camper? So, take about 45 seconds here. Turn to your partner. Think about what we just talked about. The opposite of a number. 40 is above 0. Where would you find the opposite of 40 feet above sea level? 45 seconds, go. Okay, so 40 above sea level, I know that I'm going to keep my number the same, but it's going to be that many spaces below 0. So I'm going to count down 40 spaces. That takes me to 0. To find the opposite of 40, I need to count down another 40 spaces, and negative 40 is the opposite elevation of the camper. Okay, and now it says in the space to the right, draw a visual model of the elevation of the camper and the submarine. Well, that's what I already did here. And again, this is what I want you doing every time you're looking for changes in elevation above or below sea level. Draw your vertical number line, fill your information in, and you will be doing very well with this. Okay, now, there are 3 more items in structured guided practice. And before you do anything else, I want you to draw your vertical model, draw your vertical number line, and you're going to be using this that shows the temperature changes for the 2 cities mentioned here. Remember, sea level is at 0. So put 0 and label that sea level. I don't want you just to put a 0. I want you to put what that 0 represents, sea level, when we're talking about elevations. Okay? So Work with your partner on this, and I want you to take 3 minutes to fill this in. Look for whether it's above or below, and make sure you answer 4, 5, and 6 using the vertical number line. Pause here, check back in 3 minutes. Ready? Go. And let's check and see how you did. One winter day, the high temperature in Pasadena, California was 70 degrees above zero. So I know I'm going to start at 0 and I'm going to go up 70 interval markers. There's 70 degrees. The same day, the high temperature in Newport, Rhode Island was 10 degrees below zero. Again, I'm going to go to 0 and I'm going to count down 10 degrees below 0. And remember, when you show this, you have to put your negative. And now 6 asks, what is the opposite of the temperature in Newport? Well, Newport is -10. I know that if I'm looking for an opposite number, the number is going to be the same. The sign is going to be different. So I'm going to go -10. I'm going to count up 10. That takes me to 0. Now I need to count up 10 more, and that gives me the opposite. So the opposite of -10 degrees is 10 degrees. Final check for understanding. The airplane cruised at 32,000 feet above sea level. What is the opposite rational number? And when it's final check for understanding, you are not discussing this. So I want you to read this, and I want you to, again, draw your vertical number line and indicate on your vertical number line the number and then the opposite number. And you have this item, and then there's one more for the final check for understanding. So you're going to take 2 minutes to complete items 1 and 2, and then we'll check back in. Pause the video here and go. Okay, let's check and see how you did. Again, on your number line, you're indicating 0, but you're also writing sea level. Okay, I want you to make sure you always put that in. Well, I'm going to put where the airplane cruised first, and I'm going to put my interval marker up here, and I'm going to label it 32,000 feet. Okay. Now, my directions ask for what is the opposite rational number. Well, if this is 32,000 feet, I'm going to have to count down 32,000 to get to 0, but I want the opposite. Opposite numbers are the same distance from 0, but one is a positive, the other is a negative. So the opposite number is negative 32,000 feet. And I have no doubt that's exactly what you wrote down in your book. If not, then you want to make sure you fix it. Okay, the second one. The coldest temperature ever officially recorded in the state of California is 45 degrees below 0. That is cold. And again, it's asking what is the opposite rational number. So it doesn't want to know the coldest temperature, it wants to know the opposite. So before I can find the opposite, this time I'm not going to put sea level. And this is talking about temperature. So I'm going to put 0, and this is going to be 0 degrees here. And now this is 45 degrees below 0. So I'm going to graph the temperature first. Negative 45 degrees below 0. Here's 0. I go 45 interval marks down. There's negative 45. But what I need to show is the opposite rational number. Opposite rational numbers are equidistant, or the same distance from 0. So negative 45 is 45 interval marks from 0. The opposite is going to be positive 45. And it is 45 marks above 0. So what is the opposite rational number? 45 degrees above 0. Remember, no naked numbers. You have to label what you're talking about. Okay? Now, you do not have these in your book, but I want you to, in your final check for understanding, you have some room, and I want you to do the same thing. Draw another vertical number line, and this is going to be a test to see. Not really a test. It's going to be time for you to practice a little bit more. Okay? Above sea level. So when I get to 0, when I put 0 on my vertical number line, 0, and I'm labeling it sea level. And the helicopter hovered 8,000 feet above sea level. So I'm going to graph 8,000 first on my number line. Okay, there's my 8,000 feet. What is the opposite rational number? Opposite numbers are equidistant from 0. This is 8,000 spaces from 0. This is a positive number because it's above. So an equal distance from 0 is going to be going below sea level, and that's going to be a negative 8,000. Okay, and draw your number line for this one. Temperature is 5 degrees below 0. We're talking about temperature now, so you're not going to label sea level. And you want the opposite rational number. Take 1 minute and indicate on your number line first the 5 degrees below 0, and then where the opposite rational number is. Okay, this says 5 degrees below 0. So I'm going to go to 0, below 0. I know my number is going to be lower than 0. So I'm going to graph negative 5 degrees. And now, what is the opposite rational number? Opposite numbers are equidistant from 0. So if this is negative 5, my opposite number is going to be 5 above. Okay, so there is the opposite rational number for negative 5 degrees below 0. Okay, nice job. Now, there is no homework tonight. If there is still time in the class period, a good use of your time so that you do not end up having your name left for not following directions is to read silently, or you can make up some math examples of either dividing decimals or multiplying decimals or something that we've already learned, and do that in your Swan Math book or on a separate sheet of paper. Work quietly until the end of the period, and I will see you on Tuesday. Bye for now.